Okay, hey, I want to get your questions answered on the homework assignment that is due tonight. The three most requested questions were 38, 39, and 40. They were all very similar. They all gave you one trig function, and they named one quadrant, and then the question said name or identify the values of the 5 remaining trig functions. So we know there are 6 in total. So what you're going to have to list, and I'm just going to list all 6 even though we were given one here. You're going to want to list, and I like to do it in 2 columns here, sine, cosine, tangent, and then I like to put right across from sine the reciprocal to that. Whoops. Right across from cosine, its reciprocal, which is secant, and right across from tangent, its reciprocal. So this is kind of the setup here for these problems, okay? So when they tell you that tangent is negative 2/3, they're really telling you 2 sides of the triangle. So the first thing you need to do is look at the quadrant that they've named. You're going to just place a point in quadrant 4. Okay, now you have to know quadrant 4 is this one down here in the bottom right corner. Once you've placed a point there, you're going to construct a right triangle by drawing a perpendicular line to the x-axis and then connecting that point to the origin. Always a good habit then, put that theta symbol at the angle closest to the origin. Okay, let's look back at the trig function then. It tells us that tangent is negative 2/3. Okay, so let's think about what tangent is. Tangent is opposite over adjacent. Okay, so I'm going to label 2 sides of this triangle. Opposite the theta symbol, I'm going to put a 2. And then adjacent to the theta symbol, I'm going to put a 3. Now, if you look back at this, you see that this fraction was negative. So I have to make a determination where that negative sign is going to go. Does it make more sense in my picture for me to have this vertical leg as being negative 2? Or does it make more sense that the horizontal leg would be negative 3? Well, the horizontal leg's on the positive side of the x-axis, so it makes sense that should stay positive, but you can see how the vertical leg is on the bottom half of the y-axis. That's telling me that I need to make the 2 the negative. Okay. Once I have those 2 sides labeled, I'm going to use the Pythagorean theorem to set up and solve for the hypotenuse here. Okay, I'm going to trust that you guys will be fine with going through that Pythagorean theorem here to end up getting on 38 that the hypotenuse is going to come out to be the square root of 13. So I'm going to add that to the picture. Okay, very important on these problems, you need to have this picture drawn and labeled, okay, and at least show this step of the Pythagorean theorem. Past that, once we get our picture, we're just kind of putting together then all 6 of these trig functions. Of course, we know tangent we were given was negative 2/3, so I can go ahead and fill in that cotangent would be its reciprocal. Sine should be opposite, that's going to be negative 2, over hypotenuse, that's going to be the square root of 13, and then for cosecant, I'm going to do the reciprocal, and then for cosine, I'm doing adjacent, that's the 3, over the hypotenuse of square root of 13, and then secant would be the reciprocal. Okay, so that's kind of the gist of how to go about doing those. Again, the setup is you're definitely going to want to write out your 6 trig functions. And again, I would really recommend that you kind of put them in these columns. Just makes it easier when you just have the reciprocals right next to them there. Okay, so let's look at 39 real quick. This one is naming quadrant 2. Okay, so I'm going to place a point. Okay, remember now quadrant 2 is top left. So you're going to place a point in the top left quadrant there. Anywhere you like is fine. Okay, then you're going to always connect that point to the x-axis. Okay, so you're going to connect that point to the x-axis, and then you're always going to connect it to the origin, and you're going to place the theta symbol closest to the origin. Okay, once your triangle is assembled, then you're going to look at the trig function you're given, and you're going to use the numerator and denominator to label 2 of those sides. Okay, now we know that cosine is adjacent over hypotenuse. Okay, so if we're going to label this, the adjacent leg to the theta here should be the 8. The hypotenuse should be 17. And again, looking closer here, we can see this fraction was negative. So we have to decide, should the adjacent leg be negative or should the hypotenuse be negative? Now, we've said in past lessons, the hypotenuse is never negative. Okay, so by default, the adjacent leg has to be the one that's negative. And if you look at the picture, that makes complete sense because look at where that adjacent leg is sitting. It's on the negative side of the x-axis. Okay, so now I'm going to do the Pythagorean theorem, but for this one, I'm not missing the hypotenuse, I'm missing one of the legs. So I at least want you to show this Pythagorean theorem. Again, I'm going to trust that you guys are fine with solving that equation for x. This is going to come out for x to be equal to, I think, exactly the number 15. I think the step before that we were doing the square root of maybe 225. Okay, so I'm going to go to the picture. I'm going to label 15 on the picture for that vertical leg, and I'm going to ask myself, once I put that on the picture, should I be making that 15 a negative? And the answer is no, I should not, because that vertical leg is now on the top half of the y-axis, so that should be positive. Okay, all I have left to do now is build out my 6 fractions. The one I was given was cosine, so I'm going to fill that one in, and right across from it, we're just going to do the reciprocal. Okay, sine of theta is going to be opposite, that's 15, over the hypotenuse of 17. Okay, cosecant would be the reciprocal, and then tangent is opposite, that's 15, over adjacent, the negative 8. Okay, and then cotangent would be the reciprocal. Okay, hopefully you guys are kind of getting the gist of how to do this. We'll take a quick look at number 40 here for you. Okay, number 40, again, we start with, I went ahead and kind of set that up for us here just to save some time. We're starting out with quadrant 4. Okay, that's this quadrant down here. Okay, I'm going to go ahead and construct the triangle. I'm going to place the theta symbol in, and then I'm going to look over here. Now this is cotangent. Okay, so if it's cotangent, I know cotangent is the reciprocal of tangent. So tangent is typically opposite over adjacent. So that means cotangent is adjacent over opposite. Okay, we'll worry about the negative sign in a minute. Let's just add into the picture that opposite the theta symbol, adjacent the theta symbol here, I'm going to label that as 12. And then opposite, I'm going to label that as 5. Oops. Okay, now don't be deceived. I know the way, at least that I wrote this, it looks like I was making the 12 negative. But you guys know that when you have a fraction, I mean, I can write the fraction negative 12 fifths. I can write it like that. I can write it like this. I can even put that negative sign so it just feels like it's kind of floating in the middle. It doesn't really matter where it's at. Do not assume just because this is next to the 12 that the 12 in the picture is what should be negative. If you look, you can see that that horizontal leg is actually sitting on the positive side of the x-axis. We don't want to make that negative. In fact, the leg that should be negative is this vertical leg because it's on the lower half of the y-axis. So you're always comparing the horizontal legs to the x-axis and the vertical legs to the y-axis. I need that negative sign to actually go like down here with the 5 when I add it to the picture. Okay, and then we're doing the same thing, Pythagorean theorem. This time it looks like we're missing the, oops, that's an equal sign here, missing the hypotenuse. So if we were to work this out with the hypotenuse, with the Pythagorean theorem, it looks like we're getting the hypotenuse to be 13. Remember, the hypotenuse is always positive, and then we should be good to go with building these fractions out. I'm going to start with the one that you were given. Okay, and then the rest of these is just, I think, business as usual. You guys are okay with how to build these fractions, hopefully, here. Okay. All right, I hope that that helped answer any of the questions that you guys had. If you have further questions, please reach out. This assignment is due at 10 o'clock this evening. You guys enjoy your